Greetings, my name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 4 on continuity and segment 4.2 on determining continuity. We can determine continuity for certain families of functions by recognition. We're going to look at 5 examples. First, polynomial functions are continuous for all real x. Consider the polynomial function 5x to the third minus 4x squared plus 3x minus 5. Because of this rule, I know that g of x would be continuous on the interval from negative infinity to infinity, its domain. Our second rule states that rational functions are continuous for all real x in the domain. So let's determine where this rational function is continuous. I'm going to take a look at the denominator to see where this function is undefined. So I'm going to factor this as 2x plus 1 and 2x minus 1. So I notice that this function would be discontinuous at x equal minus 1/2 by setting this equal to 0 and at x equal 1. Recall, the denominator of a rational function cannot equal 0. So that means that this function f of x is continuous on the intervals from negative infinity up to minus 1/2. Notice that I use parentheses here, and it's continuous on the interval from minus 1/2 to 1, and then from 1 to infinity. For our third example, the rule states that exponential functions are continuous for all real x. So if I have the exponential function h of x equal 3.14x, then I know that h of x is continuous on the interval from negative infinity to infinity, its domain. Fourth rule, natural log functions are continuous for all real x in the domain. So if I wanted to determine where f of x is equal to ln of x minus 2, the quantity x minus 2, then I would take x minus 2 and set it greater than 0. For the natural log function, this expression must be positive. This in turn requires that x is greater than 2. So f of x is continuous on the interval from 2 to infinity. I use a parenthesis beside the 2 because I'm not including it. And the fifth rule and the fifth example, radical functions are continuous for all real x in the domain. So let's determine where g of x is continuous. This is a radical function. The radicand, 2x minus 5, has to be greater than or equal to 0 for this function to be defined. So this forces x to be greater than or equal to 5/2. So g of x is continuous on the interval. Notice I'm using a bracket by the 5/2 because it's part of the interval. Brackets 5/2 to infinity. Well, that is it for this segment. Now you need to practice this concept by working similar problems. Good luck.